There is a machine dying in the darkness, nearly 16 billion miles from Earth, farther than any human object has ever traveled. Voyager 1 continues to drift through interstellar space. It is colder than anything most of us can imagine. Around minus 250 degrees Celsius, its metal skin frozen, its golden record bolted to its side, preserved in silence, its transmitter running on barely 22W, about the same power as a refrigerator light bulb. And yet, every single day, it tries to speak. A radio signal leaves Voyager at the speed of light. It travels for almost 24 hours before reaching Earth. A whisper from the edge of the solar system, telling us it is still there, still moving at 38,000 miles per hour, still alive. But the power is fading. The instruments are shutting down one by one. And sometime in the 2030s, that signal will stop. When it does, the farthest messenger humanity has ever sent will go silent forever. Tonight, we follow Voyager 1 from the moment it left Earth in 1977 to the final signal that will one day arrive and then never come again. Voyager 1 is now nearly 16 billion miles from Earth, almost 6 times farther than Neptune. At that distance, sunlight is about 13,000th as bright as it is on Earth. If you could stand beside it, if such a thing were possible, the sun would look like a very bright star, nothing more. There is no day, no night, just darkness. The density of interstellar space, where Voyager travels, is roughly 1 atom per cubic centimeter. It moves through a vacuum so complete that at 38,000 miles per hour, it could travel for thousands of years without encountering anything solid. And yet, it is constantly bombarded. High-energy cosmic rays from exploded stars and distant galaxies streak through its circuits. They flip bits in memory. They corrupt data. Error correction systems compensate, but the damage accumulates. Its exterior is frozen solid. Inside, small heaters struggle to keep electronics warm enough to function. Those heaters are being shut down one by one to conserve energy. There is no sound in this region of space, no air to carry vibrations. If a micrometeorite struck Voyager, there would be no crack, no echo, only silence. It is more isolated than any shipwreck, more alone than any castaway in human history. And still, somehow we can hear it. Every day, Voyager transmits a radio signal so weak that by the time it reaches Earth, the energy striking our antennas measures around 10 to the minus 16 watts, 1 part in 10 quadrillion. To capture that whisper, NASA relies on the Deep Space Network, enormous 70M dishes in California, Spain, and Australia. Even with antennas the size of sports fields, the signal is barely detectable. Voyager's transmitter uses about 22 to 23 watts to send that data, carrying temperature readings, particle counts, magnetic field measurements, and telemetry about its own condition, its orientation, its power levels, whether it is still alive. When we receive that signal, we are not hearing Voyager in real time. We are hearing it as it was almost 24 hours ago. Every transmission is proof that nearly a day earlier, it was still functioning, still surviving, still sending a heartbeat across 16 billion miles. But the signal grows weaker each year as its power supply diminishes. One day, perhaps around 2036, we will wait for that faint whisper, and it will not arrive. When Voyager 1 launched in 1977, it carried more than scientific instruments. Bolted to its side, protected by an aluminum jacket, was a 12 inches gold-plated copper disc known as the Golden Record. It was not designed to measure magnetic fields or analyze plasma. It was something far more audacious, a message. Encoded on that disc are sounds and images from Earth, greetings in 55 languages, music from different cultures, natural sounds, human voices, and diagrams showing our location in the galaxy. The record includes the rhythmic pounding of a blacksmith hammer, the sound of a mother and child, a kiss, a heartbeat, the haunting songs of humpback whales, and even the brain waves of a woman who had just fallen in love compressed into a minute of audio destined to drift for perhaps a billion years. This was not done because the odds were favorable. The engineers and scientists understood how unlikely it was that Voyager would ever encounter another civilization. But they sent it anyway, like a bottle thrown into an ocean so vast that no shore can be seen. The disk carries instructions for how to play it, diagrams explaining our solar system's position relative to pulsars, and images of human life. It is a love letter to Earth, attached to a spacecraft that is now billions of miles away from the world that created it. Out where Voyager now drifts, the golden record is silent. There is no air to carry its sounds, no listener to hear greetings spoken in 55 languages, no one to listen to Bulgarian folk music or Navajo night chants. It is a time capsule whose creators may long be gone before anyone ever finds it. Long after cities crumble and oceans change, that gold-plated disk may still be intact, protected against the harshness of space by its aluminum cover. While the spacecraft's electronics slowly fail, the record itself is designed to endure. For tens of thousands of years, Voyager will continue traveling at roughly 38,000 miles per hour. In about 40,000 years, it will pass within 1.6 light-years of star called Gliese 445. Not close enough to be captured, just drifting past. During that immense span of time, almost nothing will change for the spacecraft. It will not significantly slow down. It will not adjust course. It will simply move endlessly through a void so empty that collisions are rare. The golden record will remain attached, carrying images, sounds, and greetings from a planet that may no longer resemble the one that sent it. It is proof that for a brief moment in the darkness of cosmic history, a species looked up, wondered what lay beyond, and decided to speak. Voyager 1 launched on September 5, 1977, leaving Earth at 38,000 miles per hour, fast enough to escape the sun's gravity forever. The engineers who built it designed the mission with modest expectations, 5 years of operation, maybe 10 if everything went perfectly. The spacecraft was meant to visit Jupiter and Saturn, send back data, and eventually fail as components wore down, systems froze, and computers succumbed to radiation and cold. That was the design life. That was the plan. Instead, nearly 48 years later, Voyager 1 is still operating, still transmitting, still moving at the same relentless speed into interstellar space. In March 1979, it flew within 174,000 miles of Jupiter's cloud tops, revealing details no Earth-based telescope had ever resolved. It showed the Great Red Spot in unprecedented clarity, lightning storms flashing in Jupiter's atmosphere, auroras dancing at the poles. It revealed Io covered in active volcanoes, the first time humanity witnessed volcanic eruptions on another world. It showed Europa, a smooth sphere of ice concealing an ocean beneath. Ganymede, Callisto, worlds within worlds. Thousands of images streamed back to Earth, each one taking minutes to arrive, each one reshaping our understanding of the outer solar system. Then it used Jupiter's gravity to accelerate toward Saturn. In November 1980, it arrived, capturing the rings up close for the first time. Braided, kinked, shepherded by moons we did not even know existed. It passed within 4,000 miles of Titan, revealing a moon with an atmosphere thicker than Earth's, clouds of methane, lakes of liquid hydrocarbons. By any measure, the primary mission was complete. It had done everything it was built to do. And yet it did not stop. After Saturn, Voyager's trajectory was bent upward and out of the plane of the solar system, aimed toward interstellar space. NASA could have turned it off, shut down the instruments, let it coast silently. Instead, in 1990, 13 years after launch, Voyager was given one final assignment. Turn around. Look back. From 3.7 billion miles away, its camera captured Earth as a pale blue dot, less than a single pixel suspended in scattered sunlight. Every human who ever lived, every war, every empire, every love and loss, all contained within that tiny speck of light. After that photograph, the cameras were turned off forever. There was nothing left to photograph, only darkness ahead. In August 2012, Voyager 1 crossed the Heliosphere, the boundary where the solar wind meets the interstellar medium. It became the first human-made object to enter interstellar space. It kept moving beyond the sun's influence, beyond the protective bubble of the heliosphere, into the space between stars, nearly 16 billion miles from Earth, still traveling at 38,000 miles per hour, still transmitting data about particles, magnetic fields, and temperature. A mission designed for 5 years had become humanity's longest-running interstellar experiment. It survived radiation, freezing temperatures, cosmic rays flipping bits in its memory. It outlived expectations, outlived hardware limits, outlived what anyone thought possible, and it is still going. In November 2023, something changed. For 46 years, Voyager 1 had spoken to Earth in a clear digital language. Streams of binary data, zeros and ones, carried information about temperature, particle counts, magnetic fields, and the health of its systems. Then suddenly, the signal became unreadable. It was still transmitting. The carrier wave was still reaching Earth, but the data made no sense. Engineers described it as if Voyager's voice had been replaced with a monotonous, unchanging dial tone. 15 billion miles away, something inside the spacecraft had failed. The problem was traced to a chip inside the flight data system, a tiny piece of hardware designed in the early 1970s. Whether damaged by age or by a high-energy cosmic ray striking its circuits, the chip could no longer properly format the spacecraft's telemetry. Fixing it was not simple. Engineers at the Jet Propulsion Laboratory had to retrieve paper schematics signed in 1974, yellow documents describing hardware built nearly half a century earlier. They had to write a software fix for a computer with less memory than a modern car key. And every attempt required patience beyond anything most engineering teams ever experience. A command sent to Voyager takes roughly 23 hours to arrive, then another 23 hours to receive the response. Every adjustment meant nearly 2 days of waiting. For 5 months, there was no certainty that Voyager's voice would return. Eventually, engineers succeeded. They moved critical software to a new portion of the spacecraft's aging memory and restored readable data. Voyager spoke again, but the glitch was a warning. The mind was still functioning. The body was wearing out. Voyager 1 is powered by 3 radioisotope thermoelectric generators, devices that convert the heat of decaying plutonium-238 into electricity. At launch in 1977, they produced about 470 watts of power. Today, after 48 years, they generate roughly 220 watts, and they lose about 4 watts per year. By 2030, the available power will drop close to 200 watts, no longer enough to operate all systems. NASA has been making difficult decisions to extend the mission. Heaters have been turned off. Instruments shut down, not because they failed, but to preserve energy. In February 2025, the cosmic ray instrument was powered down to conserve electricity and keep the spacecraft alive longer. This process has been ongoing for decades. The cameras were turned off in 1990 after capturing the pale blue dot. The plasma science instrument was shut down in 2007. The planetary radio astronomy instrument followed in 2008. Each shutdown extended Voyager's life a little further. Engineers believe at least one instrument may survive into the 2030s, possibly keeping contact until around 2036. But eventually, the power will simply be insufficient. The spacecraft will not crash. It will not explode. It will not suffer a dramatic failure. It will just run out of electricity. One day, a final signal will arrive. Engineers will wait nearly 24 hours for the next transmission. It will not come. They will wait again. Nothing. And in that silence, they will know that Voyager 1, the farthest human object ever built, has sent its last message. It will still be moving at 38,000 miles per hour. It will still be drifting through interstellar space, but we will no longer hear it. Right now, Voyager 1 is still out there, nearly 16 billion miles away, moving at 38,000 miles per hour, drifting through a region so empty that even at that speed, it could travel for thousands of years without hitting anything solid. Its metal skin frozen at around minus 250 degrees Celsius. Its systems slowly shutting down, its power fading by roughly 4 watts every year. And yet, every day, a signal still arrives. A faint radio whisper that takes almost 24 hours to cross the void. A signal so weak that it reaches Earth at about 10 to the minus 16 watts. Barely detectable, fragile, but real. And every time we receive it, we know that nearly a day earlier, Voyager was still alive. It has outlived its design life by decades. It survived Jupiter's radiation, revealed volcanoes on Io, oceans beneath Europa's ice, Saturn's rings in braided detail, Titan's thick atmosphere. It turned around in 1990 and showed us the pale blue, a reminder that every human story exists on a pixel suspended in sunlight. It crossed the Heliosphere in 2012 and became the first human-made object to enter interstellar space. And bolted to its side, the golden record continues its silent journey. Greetings in 55 languages. Music, heartbeats, brainwaves. A message from a world that may one day be unrecognizable. A message that may outlive oceans, continents, civilizations. But the electricity is running out. The RTGs that once produced 470 W now generate about 220. Instruments are being shut down not because they failed, but because there's not enough power to keep them alive. One day, maybe around 2036, maybe sooner, we will wait for the next transmission, and it will not come. There will be no explosion, no dramatic ending, just silence. Voyager will keep moving. For tens of thousands of years, in about 40,000 years, it will pass within 1.6 light years of Gliese 445. Not close enough to be captured, just drifting by. It will continue for millions of years through a galaxy that will not notice its passing. The golden record will remain attached, preserved, carrying proof that once, for a brief moment in cosmic time, a species looked up and wondered. The final signal will not stop the world because it is loud. It will stop the world because it is quiet. Because in that silence, we will realize something extraordinary. We built a machine in 1977. We gave it 5 years. It lasted nearly half a century. We sent it to explore. It became our farthest ambassador. And when it goes silent, it will not be a failure. It will be a monument. If you want to continue following the real stories unfolding at the edge of human exploration, the missions that outlive generations, the signals that travel billions of miles, the discoveries still whispering from the dark, subscribe because one day the signal will stop. But the story of why we sent it never will. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.